FTC 7129, the Robo Raiders, and I'm here with Dr. Denny Davis, a retired engineering professor and current publisher and consultant of engineering education materials. And we're going to be talking about design reviews today. So, what is a design review, and how can teams benefit from them?
Well, design reviews are an important part of doing engineering design. As you know, when we're doing design, like designing our robots, we start at the beginning and move through to the end. There's an entire process. A design review is taking a pause at critical points to see that we're doing design the way it should be done. You may not realize it, but design is a combination of creative thinking and then judgmental, where we add the creativity, then we have to stop and see whether we're going in the right direction. So a design review brings us to the point where we can look and see how well we're doing those two things. So it's important for us to do reviews in order to be sure that we're doing design that's going to produce what we hope will come out the other end.
And what type of design reviews can be beneficial for FTC teams?
Design reviews for FTC teams would stop our process at critical points that might save us headache and making big mistakes. So you need to look at the process and say, well, where are some of those critical points? An important one that I see is shortly after we've done our game strategy and defined what our robot must do. Because if we have not properly defined what the robot must do, we're going to develop a robot that does something that we didn't intend or doesn't do something that's really important. So that's the first one. And then after that, you generate ideas, you come up with a concept for the way that the different systems within your robot work and put them together. It's critical that we choose the right combination before we move on. So each of these points where we stop before we make decisions that are going to be really costly if we make a bad decision.
And who can teams use when they're wanting to do a design review?
Well, when you think about design reviews, we're stopping to have a fresh look at what's going on. So, ideally, you're going to have a professional who really is good in the design of whatever you're designing to be able to critique what you're doing and give you some helpful feedback. You want them to be able to point out weaknesses, but also suggest some new ideas. Part of what we want to do is come away with some learning. We want to improve the robot that we're developing, but we also want to learn from that. We also want to build relationships with professionals so we better understand how they think. So it's important that we have these reviews, and it's ideal, as I was mentioned, to have a professional do that. But you can also just have other team members. Team members who are not intimately involved in it are going to have fresh eyes. They can ask you questions. This doesn't make sense. One of the weaknesses we have in our design is that we get so tied up in our own ideas that we don't like to be criticized. We take pride in what we have. So we need that fresh set of eyes. So basically there are two sources. One, experts, but secondarily we could have other teammates who are independent of what you're doing to give a fresh look at it.
And are design reviews only for the mechanical aspects of FTC?
No, I think we often tend to do that because that's what's obvious. But we're making critical decisions in our software, in the way we integrate things, integrate software and hardware. So a design review should be at any point in the development of software or hardware where, again, as I mentioned, there's a critical decision being made about whether we move ahead or slow down. We need, in both of those kinds of systems, to take a critical look and have a formal design review.
And how can you effectively lead a design review?
Well, obviously, when you think about the purpose of the design review, you need to have an independent look So you need to structure the review such that it's going to give you an independent, fresh look at what's going on. So ideally, you structure it by giving the reviewer some information up front so they understand the context of what you're doing, and then when they come in, you point out what it is you want from them. You want them to look at your design critically, to really understand what you're trying to do, and to make sure that your process, as well as what you're producing, both of those are consistent with the direction you're going. So at that stage, has the process been really thorough? Have you looked at everything needed in order to do a good job up to this point? And what you produced, does it make sense? Can you justify it? Can you defend it to me as a reviewer? Or do you just kind of wave your hands and say, well, this is good? So you need a process that gives the reviewer freedom to ask tough questions and give you honest feedback. And you need to give them the information that they need to do a good job of reviewing.
Thank you so much for answering my questions. Now we're going to take these principles we talked about and apply them to a real-life situation in FTC.
Hello, I am Matthew from the Robo Raiders FTC 7129, and I'm here with Dr. Davis, and we are going to be reviewing our collection system from Rover Ruckus. So this collection system was designed to be able to pick up both balls and blocks of about the same size from a fairly tight packing. They're all going to be pretty close together. So from our testing, we found that the system that was working the best was if you had two counter-rotating spinners. We tested it with rubber bands, and that's what we're using here, to be able to pull it up. That allows us to be able to collect from both the back and the front, and was very good at elevating the blocks. It could pick them up very high after they went through.
So explain to me then, we're going to review this as a conceptual design.
Yes.
Want to make sure that this concept is really going to be effective before you proceed and invest a lot of extra time and money into it. So clearly, you're talking about collecting balls and blocks. What must this do? Is there a certain number of balls and blocks that need to be collected? Do you need to get only balls, only blocks? What functionality is necessary for this to be successful?
So we can collect either balls or blocks. That doesn't matter because our other mechanisms will already be able to sort that out for us. The one thing this does need to make sure about is it only gets two. The game rules say you cannot hold 3 blocks or 3 balls, so we need to make sure it can only hold 2. That's why we have the hopper height set, so that if there are more than 2, they'll fall out.
Got it. Okay. So your rationale then is to be able to collect going forward, going back, collect only 2, get them into that hopper, and that would be success.
Yes.
What about speed? Is speed important for this?
Yes, speed was one of our main criteria with this, and speed was something that I believe this system tied on with a few others. It was basically just as fast as some of our beater bars that we tested, but we saw that this had the advantage of having more constant contact rather than a beater bar having just 2 points, whereas this one will have much more, and it having the possibility of collecting out both the back and the front.
Okay, so you just mentioned some other ideas that you looked at. An effective process means that you've looked at many different ideas. You haven't let any good idea slip by you. So what process did you use to ensure that you had all the good ideas before you locked in on this one?
First, we did brainstorming to try to think of all the different ways we could collect that, and we came up with a lot of different ways that we could collect.
Good.
And then we narrowed down to some of the more practical ones. Some of them might use more degrees of freedom than what we can use, so we limited it down to ones that could be done with like a single motor and a few servos. And then from there we tested all the promising ideas. Those were a single rubber band spinner, double rubber band spinner, beater bars, a top beater bar, and double side beater bars. And from there we found that the double rubber band spinner and the top beater bar were the 2 that were working best. and we chose the double rubber band spinner over the top beater bar because of the constant contact and the double-sidedness, which would effectively give you double the collection range, and also that it was better at elevating things than the beater bar was, so it could lift the blocks straight up rather than the beater bar needed to put them back and up.
So you're indicating that you're getting functionality for both collecting and front and back, but also elevating, so you're getting that functionality as well.
Yeah.
Okay, that sounds good. So then you now have sort of locked in on this one. What testing, what evidence do you have that this is going to efficiently collect? Do you have data to show how quickly you can pick up, how effectively it brings the balls, the blocks up, and it doesn't have a third one? In other words, what have you tested to ensure that this would indeed work?
In terms of speed and reliability, that was one of the main things that was tested on all of our prototypes. We went over a period of 10 different tests to see how long it took and then averaged that time to be able to get our average time for collecting. And we did that in a few different points on it. So whether it will collect better on the middle, the sides, or whether it will hold the right number, that is basically completely dependent on the height of this tube. So if we get our tube height right, then it won't be able to hold more. That has given us a few complications though, because if it's high enough to be able to completely contain two balls so that the balls can't be knocked out, it's very close to being able to also contain 3 blocks so that the third block is only slightly higher. So we might have problems with accidentally having 3 blocks in there, but that will require it to be completely full and the blocks perfectly stacked on top of each other.
So you're indicating a possible negative of this design.
Yes.
You could possibly get a penalty if you're carrying 3 instead of 2.
Yeah.
So what other negative impacts do you see related to this particular concept? Are there any other hazards out there that you've identified?
I think the only other possible hazard that we'd have with this design is that it is slightly more complicated than other designs, as it does have the 2 rotating bars, and running it off of 1 motor requires a little bit more gearing. That's something that can be very easily done, but it's another step of complexity over a single spinning bar system.
Okay, so it sounds like you've learned a few things from going through this prototyping exercise. You've learned the importance of trying to collect from 2 directions. You've learned that there are some hazards associated with it. Before one moves ahead, one needs to be sure that there aren't any problems that could kill it and cause you to go back and start over again. Do you see anything that, if it doesn't work, suddenly you have to go back and start over again?
So there's nothing that we've been able to find that would cause us to start over on the concept. On the design, there is a possibility. We're trying to use a lot of custom CNC parts on this, and we just got our CNC, and this will be the first system that has almost completely CNC. So if we end up messing up a lot of our CNC parts, that'll either 1, require us to just re-CNC those until we get it right, or 2, might cause us to need to redesign some of these to be able to fit off-the-shelf parts instead.
Got it.
So far, our CNC has shown to be very accurate and reliable, but we haven't been able to cut much on it yet.
Okay. So now it appears that you have good justification for proceeding. I haven't heard anything that would cause me to say that you really need to go back and redo this. So therefore, I would support you moving ahead. I would encourage you, because of some of the concerns you have, to perhaps get some additional consulting help on CNC so that you have confidence and you can do that work well. It appears to me that something like a rubber band could be fragile and break. You may want to investigate some additional elastic materials that are a little more durable. You expressed some concern about gearing and It may be that you need a more substantial support there so that your gears can't move, because you know when gears start slipping, you wear out the teeth and you can stall in the middle of the game.
Yeah. One way we've taken a preventative measure on that already is we have doubled how many gears there are here. So even if this gear starts to move or slip a little bit, it'll still be in contact with one of these gears for much longer.
Okay.
That also can spread the wear. If we are running on these two gears, it can spread the wear between those. We also chose to use a chain setup on this one, as chain normally gives a little bit more room for error, as you can add in chain tensioners like we have a hole for right here. That will give us, if the linking doesn't work out exactly perfectly, we can just make the tensioner larger or smaller to make it work.
Okay. Well, I guess in summary then, I would say it looks as if you've done an excellent job. You've thought through the problems. You've come up with at least tentative solutions to addressing them if they occur. So at this point, I would encourage you to proceed, and I congratulate you on excellent development of this concept.
Thank you. Thank you so much for taking time to come in and talk to us about this design. It's been really helpful.
Thank you for watching this final video in our Game On series on design reviews with Dr. Denny Davis. We hope this video series has been helpful to you and your team. If you have any more suggestions for video topics that we can talk about, please contact us. You can either leave a comment or contact our email or follow us on Twitter, Instagram, or Facebook. We also have a lot more resources on our website, roboraiders.net. Thanks for watching. Bye.